This is activity 1.8 on testing conductors and insulators. I have a circuit set up here, and if I connect everything, we can see that the bulb's light. This is going to be my test circuit. So I'm going to put some things within this space to test them to see if they conduct electricity or not. Some of this should be review for you. Some of this will be new maybe for some of you. So in the table, you're supposed to make a prediction first. So if you look at the table, you were supposed to go in here and make a prediction first. Is it a conductor or insulator? And then I will run through the list. That continues on the next page. And then you are to tell me if it lights or not, and then classify it as either a conductor or an insulator. So the first object I have is a key. So all I have to do is just touch on the two ends, and we can see if the bulbs light or not. The next one I have is a piece of wax paper. I'm going to clamp onto that. Okay. Now, on these clamps, we have those alligator clips that help us clamp. The next one is a piece of aluminum foil. The next one is a piece of pencil lead from a mechanical pencil. Pencil lead is made out of carbon. It's graphite. And then the next one is a pencil wood. The next one is a pipe cleaner. A pipe cleaner has this fuzzy covering on top of a piece of wire, which it will bend. If I clamp onto that, it depends on kind of how well I can get to connect with the wire that's within the fuzzy material on the pipe cleaner. If I get both of those, then it does conduct well. The next one is a rubber band. Notice how rubber's an insulator. Many tools like this have that rubber covering on the tool just in case you're working towards something electrical. It would help prevent you from being shocked. It's an insulator. Piece of string. Now I have two different paper clips here. I have one that's silver, and then I have another one that's red. So it depends on what the paper clip is made out of. The one that's silver is made out of iron. The one that's red is made out of plastic. And then the last one is a glass dropper. So that should conclude testing for insulators and conductors. For the final questions, you should be able to come up with a general characteristic of things that are conductors, what are they made out of, and general characteristic for what are insulators are made out of. Now, not everything fits into those two broad categories of what they're made out of, so we usually say they're usually made out of this type of substance. We're going to continue on with this activity 1.9. We're looking at how is the bulb wired with the wires inside of it. We call them the filament and the support wires. So I'm going to have my testing circuit set up just like this. I've got my two bulbs here. We'll see if they light up for the different things. So one of the things they're asking us to do is, so this is the tiny bulb that we're using in our circuit. This one's a little bit bigger. I'm going to use this later on. And then I even have one that's even bigger. Now, this one, I broke the glass globe away from it so that I could get to the two support wires on the inside and this filament wire that's in there too. If you look at the diagram in your packet, it kind of explains what we're talking about. So they want to know, they want us to test, do the support wires and does the filament conduct electricity? So if I clamp onto this support wire, and if I touch this one, yes, it does conduct. If I clamp onto the second support wire and touch that one, yes, it conducts. Now, my filament on here is broken, so I'm going to have to lay it like this. And I'm going to touch filament to see if it conducts. Yeah, it looks like, there we go, there's my touching it. So we know the support wires and the filament are all conductors. So now they're asking us to look at the bulb, make predictions again. So you go to this diagram, you're supposed to make predictions. Are these parts of the bulb going to conduct electricity? So give you a minute and you can make those predictions, and then we'll get started. So I'm going to use a larger bulb because that small bulb is kind of hard to do this with. So when I use this larger bulb, the first thing they're asking me is, does the glass globe conduct? The glass part of the bulb. So here I'm touching that. Does the threaded section conduct? Does the black ring conduct? Let's see the black ring on that. Oops. Here's my black ring. And then does the tip conduct? The tip is the very tip of it here. Now, they're asking us about support wires in the tip. So I'm going to have to go back to this bulb that I have broken out the parts, or broken out the globe on it. So if I look at this, I want to know, does the tip conduct? So the tip is down here, and then I'm going to go support wire. I'm going to call this wire right here my first support wire, and the tip, does that conduct? Then I want to go the support wire and the threaded, does this conduct? Nope. Then they want to go to the second support wire and the tip. So here's the second support wire and the tip. Making my contact. And then I want to go second support wire and the threaded. That does conduct. So this is telling us this one conducts electricity, this one doesn't. And then this one doesn't conduct to the threaded, but it does to the tip. So this is telling us something about how this incandescent bulb is wired. So we're looking at an incandescent bulb. So the bulb looks something like this. You have this threaded section, here's the tip, and then there's that black ring down here. This is the tip. Here's my threaded section, and then here's the bulb up here. Now I have my bulb broken so you can't see that glass piece. So what that is telling us is that one of these support wires is connected to the tip down here. The other support wire is connected to the threaded section. So in a circuit, and that would be the filament, and the filament is a tightly coiled wire. So that means in a circuit, in order to have this lighting up, I have to have the tip of the bulb connected in my closed loop, and then I have to have my threaded section connected in that closed loop. If you look at our sockets, when we clamped here to here, this one touches the bottom plate, so the tip has to be touching down on the bottom plate, which goes up, and then this top plate hits on the threaded section of the bulb. So it's the tip and the threaded section have to be in the conducting path of the bulb.